Hello, and a cold, very cold, welcome back. Today on the bench is all this white stuff. I've no idea how it got there or what it is. Seems to be some sort of fluffy substance. Anyway, enough pissing about. Let's go and have a look what's on bench. Today on the bench, for the last time, is the Mosfet amplifier. It works. However, I don't think the owner is exactly 100% chuffed because it works, but it's only got one pair of output devices, one pair of Mosfets per channel. There's a reason for that. Anyway, before we have a look at how I got here with this very lashed up setup, let's listen to some music. If I can do that without falling over and kicking cables and blowing things up. I've got it on the speakers. Coming out of both channels equally. I'm going to give it a bit of a crank up, okay. So, I mean, that's just on a pair of crap old speakers. Acoustic Solutions, I think they are. They do sound rather good on some amplifiers. These amplifiers aren't hi-fi, they're PA amplifiers in inverted commas. So, I'll short rabbit in, show you the rest of the footage as to how I got here. Onwards and upwards. Hopefully you can see the screen. I've got an end fet in there. And that is saying it's a NE-MOS blah 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 GDS 123. That is showing though that is okay. Last time I tested it, it said it was a thyristor. This tester is a bag of shite. So we'll put that down as a possible. You can't beat a curve tracer. I used to have one, but I never used it much, so never mind. Mostly I muck about with both. Try this one. Right, you see this one just reads a bit different. It just says MOS GDS. So I don't know what that means. So we'll put that as another possible. We'll put that like as a sort of second choice possible. Number 3. You can understand people struggling with this. Right, you see that one says the same, whereas the one a couple or so back gave a more complete picture. Yeah, you can understand people struggling with this. I mean, I struggle with it, and I've been mucking about with electronics for a little while. Keep pressing the wrong button. Oh, this tester really fucking tries my patience. Right, you see that one gives a more complete answer. So we'll put that like as a absolute possible, but you see the chap has marked that with a big cross saying that's a no-no. So I'm still not confident that these tests are accurate. Last one. And that one gives a, you know, more complete whatnot. I did notice though, I'm sure the last one said 4 or whatever thousand. Let me just run that past again. Yeah, you see that one is 2840M No idea what that means. VT, voltage turn on. Voltage turn on, maybe. Let's read the manual. Yeah, maybe that's the voltage turn on. So maybe this one needs more voltage to turn on. I'll have a look at the manual. Well, I'm just testing one of the P fets. Yes, I know. Don't see how the battery can be empty because it hasn't got a battery, you fuckwit. It's not a battery, it's a power supply. That's the third time I've tested it, and that said it's a diode, so we'll test that with a multimeter. And I thought that one was good, so I'll put that aside. Freaking nightmare. Pretty sure it wasn't a freaking short. Right. Part unknown or damaged. Okie doke. Maybe it just can't test P lateral fets. So let's go and find some more. Okay, right, that's sort of maybe then. Put that in the possible pile. Got one more. See, that one gives a more complete answer. So we'll put that as a definite possible, but for comparison, a very, very kind friend gave me a new old stock pair of lateral fets, and we'll test those. As you can see, these are bigger and they're slightly different to the other ones. I'm just going to handle them gingerly until I make sure I ain't going to short them out. These are BUZ 901 CDP and BUZ 906 DP Semilab. That's what the SML means. Right, let me go and touch the socket of my scope, which will ground me and make sure I'm not got any static on there. Right, let's test them. Still going to handle them gingerly though, because these are rare as rocking or shit. Right. Okay, technology. Right, you see that gives a more complete answer. Right, VT 230N M. This is my test setup. Split rail 30 volts, plus minus negative. This is my power supply. Plus 15 volts, minus 15 volts. Across that I've got the pot. Got this little holder here to pop the fet in, and then from the positive to the drain, this is for testing end fets. Got an LED with a drop-in resistor, and going from the wiper of the pot to the gate of the device under test is a 1K resistor. So we'll pop that in. So we should be able to turn this on and off. Right, and the LED isn't always on, so that's a good, or a possible good one. This is one I tested earlier that didn't test okay, and now you see even that one is testing okay. Right. With this one, got to jerry rig the source. Hold on, the pin's broken off. Blip, blip, blip. See, that one's showing as always on, so even though that sort of tested okay on that other tester, this is showing that it's a short. And this is a duff one as well. Can you see the LEDs on? And it doesn't matter how I adjust the pot, that's duff, even though it tested sort of okay in the tester. Just goes to show, eh? Testing the fets. Got this one, as you can see. That one seems to be working. And this one just sort of working. Let's test the ones that the tester rejected. Confirmed dead short. I haven't tested them with the meter just yet. Yeah, knackered. So that means we've only got one. It means we've got 4 possible end fets, 1 possible P fet. Had a few days off messing about with valves just to restore my sanity. Still got the, as far as I know, genuine Hitachi 2SJ353 2SK treble 2 ones, just one pairing. These are the replacements for the BUZ, etc. You should know all that by now. Last time I fired it up, these were getting a lot warmer than the good amp, so I put these heat sinks on. At the moment they're not too bad, so just leaving that to, you know, warm up whatever it wants to do. I've also got a voltmeter lead there checking the offset. So glare, right, which you can see is 100 and let's call that 120 millivolts. All transistor amplifiers have a DC offset, depending on its topology and all the rest of it. It should be as low as possible, because you do not want, this is DC voltage by the way, you do not want DC voltage on your speakers, because it'll fuck them up, it'll cook them, it'll burn out the voice coils. So it's a big no-no. I checked the good amplifier before I took it apart, I'll get to that in a minute, a little while back, and it was about 150 millivolts, which is quite a lot really in terms of DC offset. That is, yeah, quite a bit. And that was with just a 8 ohm dummy load, pure resistive dummy load. So I'm just going to keep checking these buggers. Yeah, they're starting to get warm now. And I think, well, it's a DC coupled amplifier. It's inherent in the design. There's nothing much I can do about that, apart from try to get the BJT driver voltage amplifier bias stage as good as we can get it. Well, looking at it, I mean, I'm still on the lamp limiter and I've still got the 100 ohm current limiting resistors in there. As far as I can see, it's a bit lower than the good, in inverted commas, amplifier. What it will do though is go up if I attach a load. I'm just going to call it out because I don't want to start sodding about. So it's about 100 millivolts at the moment. I've just touched that lead to ground and it's gone up to 120 milliamps. So there's a difference of about 20 milliamps. Anyway, yeah, I can feel that it's getting rather warm, so I'm going to cut it off there and then tell you what I've done. This is the good channel. What I've done, I've taken a couple of the BU Z blah 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 transistors that was on this board, because after testing all the MOSFETs, the Hitachi MOSFETs, if that's what they are, and let's just presume that they are, I only had I think we had about 4 good fets and only 1 good P-FET. So we can either do one or two things. We can either get another P-FET and put that on, but we've still got this overheating problem, and I can't understand for me why it should be getting particularly warm, because the bias conditions are the same as far as I can see, you know, I mean, it's a very tiny little difference, are the same for this Duff channel and the good one. They're about the same, and that is 0.5 volts on the NFETs and about 0.2 volts for the PFETs. That should not turn on a MOSFET enough whereby it's getting really hot. It shouldn't. Keep reiterating, a MOSFET is a voltage control device. You need about like 12 volts gate source voltage to turn the buggers on full, so that they're really cooking. Like less than 1 volt is not, or it should not be enough to get them hot. So we could have ordered another P-FET, or I suggested that we pull a couple of transistors off the good amplifier, pop them on and see if they get hot. Then we will know whether it's like the Duff board being still wrong, or whether the MOSFETs that I'm using on the Duff board are either fakes, dodgy, or it could be that they just have different operating parameters. I haven't dived into that just yet. I haven't compared the data sheets, the RDS on and all the rest of it, and gone into the parameters of the two different sorts of output devices that we've got. So I'm going to bung them on, see if they get hot, and we'll take it from there. Alright, after a false start where I got plus 30 volts on this resistor here, where it should be 0.5 or something thereabouts, which was down to a broken trace around this BJT stage. I've got the two BUZ original output devices out of the good channel, and they are getting warm, but it's not uncomfortable. So these Hitachi devices were getting far hotter. When I put those two in there, I was uncomfortable enough where I had to put heatsinks on them. They were getting noticeably toasty. I mean, it's all subjective, so, but every parameter that I took off the good working amplifier is correct. So I concur from that either these aren't quite genuine, or that they have different parameters. I've pulled the data sheets for everything. I'm going to look at that, run it past the boffins on the forum, see what they say, whether they got, I think the only thing really that would affect this sort of thing is like a different RDS on, or what that means is the drain source resistance when they're turned on. The capacitance has something to do with MOSFETs as well. Again, not an expert. So yeah, I don't know. So we've got a few options open to us. Either we get another replacement PFET and put 2 pairs on, or I suggested to the owner just like taking a, you know, a pair out of the good channel, chucking them on. And Rod Elliott in his he basically designed a lateral MOSFET amplifier using hexagon devices, so different output devices again, but lateral MOSFETs, and he suggested like on just using 2 pairs, using a power supply of 42 volts, not going any more than that. But that also depends on what load this is going to be used with a, so basically this has an unloaded voltage of about 50 volts, plus minus 50 volts. With an 8 ohm load that might be fine. With a 4 ohm load then it might be cooking or blowing the MOSFET. So I might need to find like either a different transformer or something, or just change the power supply, bung in a couple of resistors or something to drop it. I don't know. And then of course, I mean, I could like give this back to the owner and say, right, there you go, it's working, everything's cushy, but we still have this issue where with some loads the damn things are oscillating, hence burnt out resistor there, burnt out crowbar resistor there. And is there any visual damage on this one? No, but I mean it's a potential. So if I do chuck it back together just with 2 or 4 or whatever, I'm gonna tack on some gate source Zener diodes back to back to protect that. Chuck a diode, a reverse bias diode, across the gate resistor, and I don't know, maybe try and sort the protection out, the protection circuit out a little bit better. But yeah, I don't know. Already I've chucked loads of time at this, more time than I wanted to, so I don't really want to be chucking more time at it because I've got things of my own to do. But still, if you're gonna do a job, do the plug. If you're going to do a job, do the bugger properly. Right, that's all for now, and it's getting dark. Daughter's home soon. Have a chat with the owner and the boffins, and see you in the morning. Another day on this amplifier, and I really want to wrap it up soon because I put a lot of time into it, etc. As you saw yesterday, hopefully I got that footage, I took 2 good fets out of the good channel, tried them on the bad channel, and they run a lot cooler than the 2SK, 2SJ Hitachi fets. So what I'm going to do, what I've recommended to the owner, is to replace the toroid with a lower voltage one, which I've got, so that we a rails or something like 42 volts instead of the nearly 50 volts. Run them just with 1 pair of fets in, And so towards that end, what I'm going to do, I'm going to put them into this heatsink here, make a couple of mica insulators up, and then give it a pretty good thorough testing as to output power, distortion, stability and all that sort of thing. So let's do that and see what the crack is. Before I mount the output devices to the heatsink, I've gone over it with a bit of flat steel with a bit of wet and dry, and just got the surfaces sort of flat as I can get it. The other thing I'm going to do as well, prior to fitting, is use a couple of, I think these are 10 volt Zenas, so they'll be sort of back to back, like I'll show you in a minute with a schematic. So I'm going to do that from the gate to the source. The BUZ 905 maximum gate source voltage is 14 volts. They shouldn't see anything like that RMS. I'm not sure whether that's RMS or peak to peak, like in terms of drive voltage, so I think we'll try a couple of 10 volt Zenas, and that will just clamp the gate source voltage in case there's any sort of massive peaks or anything like that. Voltage peaks, that is, obviously. I'm about to apply a bit of heatsink compound, but it's very cold today and this stuff is thick anyway, so I've just got a bit of acetone to thin it down on a cotton bud, and I'm just gonna water it down a bit with that, mix it into a paste. And then remove any excess. Only need a little bit just to make sure it makes good contact. See, it's really thick bloody stuff. Just going to put a merest smear on that. It's a bit too much on that one. Get a bit off. Unlike a lot of techs, I don't really mind the stuff on my fingers. It's just, yeah, compared to some of the other stuff these hands have seen over the years, it's no biggie, but I can understand people not liking it. Here we are the next morning, ready to do a test. I've already done some preliminary testing but not filmed it. Sometimes, you know, you don't want to be filming when you're messing about with stuff, because, you know, you need to concentrate. Anyway, I can't remember whether I filmed this bit yesterday. Let me turn the bugger off so I'm not going to make it go bang. I fitted a 1 ohm resistor, 22 turns of wire around it, and cut the trace that's there to try to make it more stable. Also soldered a couple of anode to anode back to back Zenas, 10 volt Zenas, across the gate and the source to try to give the Mosfets a bit more protection. I've got a 1 volt RMS sine wave, 1 kilohertz sine wave going in. Let's power it up. At the moment I've got it pretty much rail wise, voltage wise, where it probably would be with full mains. It's still on the variac, but all the current limiting is off. And I'll point you at the scope and turn the turn the volume up. 3 volts RMS. Let's put it to about 6 because that's where it would be sort of listening wise. It's on a dummy load, 8 ohm dummy load. 6 volt RMS. Wait. I don't know if I can just done that. Right, it's my bloody scope playing silly buggers. It's always something. Right, 6 volts RMS. 0.02 THD. Okay. I think that's my scope, not the hacking thing. Yeah, it's my scope plate. Oh, God, Jesus Christ. You just want to weep sometimes, don't you? And go and throw yourself in the canal. Right, where are we? Right, AC levels. Crank it up. It's probably my leads as well, test leads. I really need some bloody decent BNC leads. Yes, you can still see that. Keep forgetting you're there. Cranky, cranky, cranky. 4 volts. 12 volts, 13 volts, 17 volts. Just starts to clip there, look, and we're at 24 volts. Right, I'm not going to keep it there because I don't want to blow the fucker up. 24 volts, 24 times 24, in other words squared, equals 576 divided by 8. 72 watts, which is what I thought it would be. So that's not bad. That's not too bad. I mean, 72 watts is more than enough for a you know, fucking amplifier, I think anyway. It was never gonna do, even with another pair of MOSFETs in there. It was never gonna do 200 watts. I did have a look at the distortion at full power earlier on. That was quite respectable. Shall we have I'll point you at the analyzer, shall I? Oh, let's try again. I've sorted my test gear out a bit, wired it up a bit different, so we've got about 5 volts RMS coming out the output, 1 kilohertz. If I chuck in 100 hertz, you can see it doesn't get noticeably any different, and according to my audio analyzer, at 100 hertz we're down minus 0.43. Don't forget the minus. Let's chuck it down to 20 hertz. And we're down about 6 dB at 20 hertz. So we're back to our reference, which is 1 kilohertz, 0 dB. Let's try it at 10 kilohertz, and at 10 kilohertz we're down 0.4 dB, let's call that. We're down 1.4 there at 20 kilohertz. And our 3 dB point is at 30 kilohertz. So yeah, it seems to be a lot better than it was before. Now though, we need to give it a bit of a harder test, and that's to put a capacitive load on the output instead of a resistive load, and see how it handles it. Right, on the screen is a 1 kilohertz sine wave, square wave. bit of rounding off, but I can't see any instability. Let me just do you in a bit more there. There we go. Well, let's chuck it down to 100 Hertz. Sort the time base out, and as you can see here, we've got a lot of low frequency roll off because it goes down like that. If it was going up, that would be high frequency roll off. Let's chuck it onto 10 kilohertz. And again, I can't see any signs of instability, but I am only doing quite low. And just keep changing. A lot to think about while you're doing this. Right, I don't know what the output is because I haven't got it monitored by a what's it, but I can't. There's a little bit there. See if I can zoom in onto that. Where are we? No, I can't. Hold on. I could if I actually messed about with the scope a bit more. See there? That rounding off there is just like a tiny little bit of sort of oscillation, but it's not too bad. Let me just reduce that and put the scope on the before that coil that I put in. So this is a sort of pure output, as it were. Mind you, I haven't changed the load, so before that. Right, I know that's not really telling us. Well, that's as far as I'm going to push this amplifier. As far as I know, this coil here and the 1 ohm resistor is doing its job. I need to tidy that up. It's just got a bit of Captain tape around it, just needs sticking down properly. So the next thing to do is get the duff channel, put a couple of good fets in that came out of this channel, fit the volume control, the potentiometer, the Bourne's pot, chuck it all back together, and then actually listen to some music through it. Okie dokie, so we're back to the beginning then, essentially, where I put the music on. This Mosfet amplifier has been a bit of a sod to try and fix. The PCB of the Duff amplifier, the one that was giving all the problems, is essentially hanging on by a thread. It's very sensitive to any touch and all the rest of it, but I've done the best that I can with the resources that I had. If I'd have had like a curve tracer to test those Hitachi fets, we might have got to the bottom of why they were getting so hot, but I just did not trust them, and I could not sanction the idea of giving the amplifier back to the chap potentially with a catastrophic fault. He might have taken out the transformer, the mains transformer and everything. So I did the best that I could with what I had. So hopefully you learnt something from all that testing and the testing of the MOSFETs and what have you. As you saw, you can't really rely on one of those cheap testers to test any device really, because they give so, well, particularly, I mean, in this case, that one gives ambiguous results. Anywho, bit of a long one, lads and lasses. Thank you very much for watching. Take care of yourselves. Ta-ra for now.